Good morning, all of you. So, in yesterday's class, we have learned radioactive decay law. Now, today, activity that is R. It is very simple. See here, activity is what? Number of decays per unit time. So, if R is the activity, then this R is equal to dN by dt. Okay, R is equal to what? dN by dt. Now, N we know, let's substitute that R is equal to d dt of, from yesterday's law, n is equal to what? N0 e power minus lambda t. Yes, so I have substituted that. And now let's take differentiation. So R is equal to lambda n, that is equal to lambda n naught e power minus lambda t. Okay, so if we will take differentiation of this, we will get this, and this is lambda n. So if I am assuming that this is a R naught value, then R is equal to R naught e power minus lambda t. Okay, where you can write here, that is R0 is equal to lambda into n naught. Okay, this, whatever this part is nothing but R naught. Okay, now what is the SI unit of this activity? So this SI unit is becquerel, and denoted by BQ. We will see conversions also, because sometimes we are using another units instead of becquerel, that is Rutherford and Curie. So let's see conversion also. 1 becquerel is equal to 1 decay per second. This is standard unit, we can say 1 decay per second. Next, 1 Rutherford is equal to 10 power 6 decay per second, that is becquerel also you can say, just becquerel I am using. And 1 Curie is equal to 3.7 into 10 to the power 10 becquerel, or you can say decay per second. Got it? So this is what the conversions of units of activity. Okay. Next one is decay constant. Decay constant. How we can define this? We can define like this: reciprocal of time during which the number of nuclei decreases to 1 by E times their original value. Okay, what is that? Reciprocal of time during which number of nuclei decreases to 1 by E times their original value. If we will plot one small graph, you will understand. I am plotting here at the bottom, you can see. Okay, wait, I will draw it on next page. This is 1 by lambda. This is time on this axis. This value is n0. We know initial value of number of nuclei. And this one is what? N0 by E. This is what your decay constant. And on this y-axis, what we have taken? We have taken n, number of nuclei. Okay, got it? This is what decay constant definition. Next one, what is half-life? Half-life. Okay, so this is half-life. So see, in a name itself, half-life, how we can define half-life? So see, can I say like this? Time interval during which the number of radioactive nuclei disintegrate to half of its original value. Means suppose, let us take one common example. Suppose I am having 100 number of nuclides. Initial number is how much? 100. Now after time, suppose let us take 120 second. Okay, how much time? After 120 second, this number of nuclei becomes 50. Number of nuclei becomes 50. So can I say that this 120 second is a half life? Yes. What is this? Half life. Why? Because the time at which number of nuclei becomes half of original value, in a simple language. Yes. So that is what half life is. So let's write the definition of this. This is time interval during which the number of radioactive nuclei of a sample disintegrate to half of its original value. Half of its original value. The interval during which the number of radioactive nuclei of a sample disintegrate to half of its original value. Already I have explained this, right? Next one, what is relation between decay constant and half-life period? Let's see. Relation between lambda and half-life period. Lambda means decay constant. Relation between lambda and half-life period. Now, we know one relation, that is n is equal to, or n by n naught. Anything you can write. N is equal to n naught into e power minus lambda t, you write. That is radioactive decay law. Or n by n naught is equal to e power minus lambda t. Anything you can write. So we know this radioactive decay law, n is equal to n naught e power minus lambda t. So therefore, This n naught I am transferring this side. So this is n by n naught is equal to e power minus lambda t. E power minus lambda t. Now n is equal to what here? N0 by 2, because initial number of nuclei are n0 and n is equal to what? N0 by 2. As I told one example, 100 nuclei was there and later how much left? Only 50. So that is nothing but 100 by 2. So therefore n is equal to n0 by 2, and here small t time is equal to what? Half life, that is t. Then let's substitute in this what we are getting. So therefore n naught by 2 divided by n naught is equal to e power minus lambda capital T. Got it? Yes. Now this n naught and this n naught will get cancelled. This n naught cancels with this n naught. So what is left now? 1 by 2 is equal to e power minus lambda t. Now taking log on both sides, or else this one you can write like this also. How? 1 by 2 is equal to 1 by e power lambda t. Minus power I have taken denominator. So taking reciprocal, you are getting 2 is equal to e power lambda t only. I have taken reciprocal. Now for removing this I am taking log. So therefore ln of 2 is equal to lambda t. Right? Yes. ln of 2 is equal to lambda t. Next. Now we got this. So if I want capital T, then capital T is equal to what? ln of 2 by lambda. So capital T is equal to ln of 2 divided by lambda. Okay. Now this is log to the base e. I am converting to log to the base 10. So therefore P is equal to 2.303 log to the base 10 of 2 total divided by lambda. Yes. And if you will do this by finding this log and all, how much you are getting value? 0.693 divided by lambda. So this is what the relation between half-life and decay constant. Half-life and decay constant. So first note down this part. Yes. And this is what the next one you can write down. Yes. One note point below you can write. Note point. The number of nuclei remain in the sample after half of half-life. Or half-life period is. N by N naught is equal to 1 by 2 whole power N. Next one, average life or mean life. Average life or mean life. Average life or mean life. This is denoted by like this. How we are denoting torque, like that we should denote it. Okay, this is what average life or mean life. Average life or mean life. So first, what is this average life? So first we will see definition. The total lifetime lifetime of all the nuclei divided by total number of original nuclei. Total number of original nuclei. The total lifetime of all the nuclei divided by total number of original nuclei. So how we can write this mathematically? Tau is equal to integration of T into dn divided by n naught. But we know, I am doing this side, minus dn by dt is equal to lambda t, lambda n, है ना? So I am writing here n is our radioactive decay law, and therefore dn is equal to minus lambda n dt. I have transferred this term this side, and now again I know n is equal to what? N0 e power minus lambda t. Let's substitute here. So dn value what I am getting, minus lambda into n naught e power minus lambda t into dt. This is what dn value. Now let's substitute here. So what I am getting, this tau is equal to integration of t into minus lambda n naught e power minus lambda t into dt divided by n naught, and this integration from 0 to infinity. So this n naught and this n naught I am cancelling, and let's take lambda outside. So what we are getting, integration t into e power minus lambda t dt from 0 to infinity. This is minus here. Okay. If we will solve this by parts, we will get tau is equal to 1 by lambda. Tau is equal to what? 1 by lambda. This is what the relation between decay constant and half-life. Decay constant and average life, not half-life. So therefore, this tau is equal to 1 by lambda. Okay. This is what the formula for average life or mean life. So how we can define it as this? Can I say like this? Reciprocal of decay constant. Reciprocal of decay constant is your half-life. Okay, reciprocal of decay constant is what? Half-life. Next one, relation between half-life and average life. What is that? Relation between half-life and average life. Average life means mean life. Half-life is denoted by capital T. Average life is denoted by tau. This is what relation between half-life and average life. So let's see. Now we have two relations. You can see backside. Yes, here it is. What we got? T is equal to 0.693 by lambda, and this we got tau is equal to 1 by lambda. So we are having two equations. T is equal to, that is what, half-life 0.693 divided by lambda, and tau is equal to 1 by lambda. Now this T is equal to 0.693 into 1 by lambda. So therefore this T is equal to 0.693 into this tau. Clear? Right? And if you want this, so this tau is equal to capital T by 0.693, and therefore this tau is equal to 1.443 into capital T. So these two formulas you can keep it in mind to calculate half-life or average life. Anyone is given. One note point: probability survival of nucleus, probability survival of nucleus after time n by n naught is equal to e power minus lambda t, which is equal to ps, and next one, probability This is for survival, okay? And probability of nucleus to disintegrate. Probability of nucleus to disintegrate in time t is P of disintegration is equal to 1 minus probability of survival. So this is equal to what? 1 minus e power minus lambda t. If they are asking you this probability also, you can use these two formulas. Got it? Right? And one more, lambda a into Na is equal to lambda of b into n of b. So this is if they are giving number of nuclei and disintegration constant, then you can use this formula. Clear? Understood? So note down this carefully. If you have doubt, you can call me. And let's stop here for today.